No, you, yeah.
Hello everyone. Our group name is Yan2badulla. My name is Zaya Jose Wu, and my friend name is Supipi. And today we'll be discussing on the topic named Emotion Aware Mental Health Chatbot with Scalable ML Pipeline. So for our contest for today, we have introduction, existing problems, literature review, proposed solution, project objectives, use data sets, proposed methodology, retraining strategy, system architecture, technical innovation, experimental plan, evaluation metrics, feasibility and tools, and expected contributions. So, for the introduction, mental health issues such as stress, anxiety, and emotional distress are increasing very common in our modern society because many individuals they are hesitant to share their emotions with others. They also fear social stigma or judgment. They also lack immediate access to mental health support. So, as a result, many people remain without timely emotional assistance. So we have discussed how about an AI-powered chatbot for mental health support to give immediate interaction, for private communication, and for emotion-aware responses. And of course, in this society, we still have existing problems in some projects because many existing chatbot systems they have several limitations. They rely on rule-based or predefined responses. They cannot also accurately understand user emotion. They lack empathetic and context-aware communication. In addition, deploying real-world AI system also requires scalable data pipelines, reliable model deployment, continuous monitoring, and retraining. So for our literature review, we're going to be discussing about related works and research gap. So for related works, we have one mental chatbot which has already been implemented and another research paper that has discussed on the mental chatbot with using the AWS pipeline. And of course, for the first one is robot mental health chatbot, which it is introduced by Dr. Alison Darcy in 2017. It is an artificial intelligence powered conversational agent that delivers mental health support using evidence-based models. The pipeline is that when a user sends a message through messaging interface, the NLP models from the backend they performs text processing, intent detection, and sentiment analysis. The model used in there are BERT, and it also includes dialogue management component, which determines appropriate conversation, which will be given back to the user. So for another related work is cloud-based chatbot using AWS services and AI to communicate with humans to analyze your mental health and provide their needs. It follows a cloud-based machine learning and conversational pipeline, which is implemented with Amazon Lex, Semindo Lambda, and Twilio. And for the pipeline summary, the it first collects conversational mental health interaction data and train the NLP models within Lex. And then the chatbot pipeline determines and starts when a user sends a message through SMS via Twilio, which forwards the request to Amazon Lex. And then the Lex performs NLP processing and invokes the AWS Lambda functions that analyzes users' mental health condition. And also Lambda functions send responses to Lex and the Lex generates structured replies through Twilio to user. So for our research gap, for robot, it does not incorporate multimodal data such as emotional state, behavioral signals, and also it is not implemented. It has not implemented cloud services, which mainly focuses, and it only mainly focuses on therapy delivery rather than the responsive results. And for the second one, the cloud-based chatbot, they it did not specifically describe the use of large-scale label mental health datasets or detailed machine learning training procedures. The lack of integrated data pipelines for both real-time emotional analysis and long-term data storage, which they also lack multimodal data analysis such as speech. So, can our proposed solution fill the gaps? The answer is yes, because we have improving contextual understanding and emotional analysis through more advanced NLP technique. We also combine the two architectures, NLP and AWS pipeline, which allow our chatbot to handle larger volumes of data and users while maintaining the real-time responsive interactions. We also focuses on enhancing personalization and accessibility by providing structured mental health guidance and resources based on users' emotional states, thereby addressing the limitations of earlier system in terms of scalability, adaptability, faster speech, emotional data sets, and cloud-based deployment for real-world mental health support. So our proposed solutions, our system that we have developed a system that can detect emotions from user messages, generate empathetic responses, operates within a scalable machine learning pipeline, and which in turn it gives us our emotion aware mental health chatbot system. we have our project objectives, which the main objective is to develop an emotion-aware chatbot system that can detect user emotion and generate empathetic responses using machine learning and scalable cloud pipeline. We also have our sub-objectives, which detects user emotion from text, generate empathetic responses, build a data engineering pipeline, deploy chatbot using AWS cloud services, and implement CI/CD retraining workflow. For our database that we have used, the first database is called the Air AI Emotion, which it is sourced from Hugging Face. Our data set it contains short sentences collected from social media, and each sentence is labeled within an emotional category. We also have a total of over 2,000 to 20,000 samples records, and we have two columns in the data set, which are the text and the label. And we are going to use the classification model to classify the six emotion classes, which are sadness, joy, love, anger, fear, and surprise. This data set will be mainly used for the emotion classification model in the chatbot system. So for our second data set, we have empathetic dialogues, which is derived from Facebook and AI. And our source is Kaggle. For our dataset overview, it contains conversations designed to model empathetic communication. Dialogues are based on emotion-related personal situations. Each conversation includes a speaker sharing experience and a listener responding empathetically. And we have a total records of over 25,000 conversation. And our main columns include COVID ID, which is unique conversation identifier, and utterance mostly spoken by the participant, emotion, which is emotion associated with the situation, and our speaker index, which identify the speaker in the conversation. This dataset will be used for training the response generation model in the chatbot system.
Uh, in our proposed methodology, our system workflow has several steps. So the first is the process starts when the user sends a message to the chatbot. So the message is undergoing the text pre-processing, and the clean text will be go to the emotional classifier model. So here we will use the distilled word classifier, and the detected emotion will be sent to the response generator. For this one, we will use the T5 model generator, and then the created response will be sent back to the user. For the data storage, all the interactions are recorded for the monitoring and model enhancement. So as the data, so we will store user message, detected emotional label, generated response, timestamp, model prediction, confidence, and response latency. And also for the system monitoring, so we will use Amazon services. So that services will track the model prediction accuracy, model emotion distribution changes in records, stored records, and response latency, error rates, and the API usage. So, and also in our proposed methodology, so we have another component model retraining. So our system will supports automated retraining. So when our predefined conditions are met, so the proposed models will be retrained using CI/CD pipeline. So where we will use the GitHub, and also we will use Amazon ECR to push our newly implemented models to our pipeline. So what are the two conditions we have defined to retrain our models? Well, the one is, so why we have why we have introduced these retraining strategies this is to avoid unnecessary retraining. So from which one we can reduce our cost for the pipeline system as well. The first condition is accumulation of new conversation and data. So that means we are storing user and chatbot interaction records, where when our S3 storage have newly added records are more than 1,000, let's say. So then our system will trigger another lambda, so that will allow to retrain our models. So why we are having this kind of retraining strategy? Because from the new record chat, so we can identify users new language pattern. So according to that one, our chatbot can adapt to the user's real behavior. So then the second condition is the significant change in emotion distributions. So we will store a user chatbot interaction in our databases. So there, sometimes when we compare with the original data and the recent data is stored in the S3 buckets or the DynamoDB, so we can see if the emotion records distributions are differentiated. For an example, if it is sadness, the previously it was 30% records from the whole data set, but now it will be 55%. So then we will let our models to retrain again, because so this retrain condition, what it will do is, because when the particular emission is significantly increased, means the user in that situation, so that our model will be adapted to that emotional states. So this is a system architecture pipeline. So first, the user will interact with the chatbot using the web application. So the his request will be going through the Amazon API gateway. So then the request will be triggers an AWS Lambda. So that Lambda will run in Docker container. So that container will have the our machine learning models and tokenizers. And inside the tokenizer, what our models are, as I mentioned previously, the emotion detector and response generators. And and also each interaction will be saved in S3, Amazon S3 and the Dynamo. So Amazon S3 for chat logs, and for the Dynamo for the structured conversation records. And also we will use the Amazon a cloud watch, so to monitor the system activity and logs and the performance metrics. I told you, so we will have a scheduled task, so from which one the our another AWS will be trigger to analyze the chat logs in our stored data, and it will detect whether retraining should be triggered or not. For that one, we will use the Amazon event bridge to trigger this AWS Lambda functions. So if the conditions are satisfied, so the it will trigger the GitHub action CI/CD pipeline will be retrained the model. So it will unbuild the new Docker image. It will push to the AWS ECR, and it will redeploy into our Lambda again to use the new models. So this architecture will create a continuous learning pipeline. So where chatbot improve will be automatically according to the user interactions. So for the technical innovation, so we will use the light transform models to have the fast inference and the serverless deployment using AWS Lambda. So Docker containerized machine learning models, event-driven training pipeline in batch wise. So as I tell you, so we will check periodically the log image or log records to retrain the models, but here we will not continuously check in the logs, because it will cause for the cost. What we are doing is we will do in batch wise. For an example, we will allow that Lambda function to be triggered to analyze the records after every 20 hours. So because of that one, so we will have a cost-effective system, scalable architecture, and continuous model improvement. So our experiment plan is the user chatbot interacts to the web interface. So we will store the chatbot interaction data in Amazon S3 and the DynamoDB according to the data type. And then we will monitor the system activity and the log using the Amazon cloud watch, and then using the Amazon event bridge with AWS Lambda. So we will periodically, batch wise, will analyze the chat logs stored in S3. So it is not practical to check the pipeline operation with the predefined conditions we have discussed in previous slides. For an example, so we have to wait until 1,000 records are available in our stored records. So what we are doing is, in the evaluation plan, so we will upload generated chat logs to the Amazon S3 to check whether the triggering is working well. To verify CI/CD pipeline, so we will build a Docker image, a new Docker image, and we will push it to the Amazon ECR, and we'll try to deploy into our Lambda model again. For the evaluation, for the classification model, accuracy, precision, recall, and F1 score will be used. For the response generator, blue score, rough score, and perplexity is used because this is related to NLP task. System performance will be evaluated using latency and throughput characteristics. So for the feasibility and tools, we will use Python, PyTorch as a programming language. For the models, Hugging Face transformers will be used. For the cloud infrastructure, whatever we have discussed in the previous slides will be used. And for the developed tools, Docker and the GitHub. For the cost is effective strategy. So we will use the small models and we will train the models locally, and we will use the serverless AWS services, and we will retrain the model when we need in batch wise. So for our expected contribution from our project is emotion aware chatbot for mental health support. So it is end-to-end machine learning pipeline model. So it is deployed in cloud-based, and it has the capability of continuous learning using interaction data. So it is cost-effective, scalable, accurate chatbot system. That is our presentation. Thank you.